Today we'll be looking at the Unit 2 test review, which is on linear and exponential functions. So we can ignore that part. In the first part we're going to be asking, are these linear, exponential, or neither? Now in class we did a little pointer exercise, but you can point to the correct answer with your pointer on the video. So this first one, is this linear, exponential, or neither? Point to the one you think is the correct answer. This one is exponential. This one is exponential because we have an x in the exponent. All right, let's look at the next one. How about this one? Is this linear, exponential, or neither? This one is linear because it's in the form mx plus b. That helps us know that it is a linear equation. How about this one? Linear, exponential, or neither? This one is exponential. Yes, because of that x. X in the exponent tells us this is exponential. All right, now we're going to be adding discrete or continuous. So we're still asking, is it linear or exponential? But now, is it discrete or continuous? What do you think about this one? Point to the one you think it is. This is exponential continuous. You can see all of the points are connected. That makes it continuous. And then it's a curve, so we expect this to be exponential. For every A Takara earns, their parents pay them $5. What type of equation is this? This is linear discrete because we're adding each time. Adding tells us it's arithmetic or linear. And then discrete is because it's in chunks. We get $5 at a time, $5, $10, $15, but all the amounts in between aren't covered. So since you can't get half of that amount, there's no point at 250. This is discrete. How about this one? This is exponential discrete. It's a curve and it's dots that are not connected, so it's discrete. And this one? It's a straight line. All the dots are connected, so this is linear continuous. Straight line, and it continues between all the dots. Julian takes 5 milligrams of medicine at 9 a.m. The medicine leaves their bloodstream at a rate of 2% per hour. What kind of equation is this describing? This is exponential continuous. That's because, so remember when we said percentages are typically a good indication that you're probably going to be looking at exponential, because percentages usually mean multiply. And then the medicine doesn't leave in big chunks. It is continuously leaving the bloodstream. It's continuously degrading out of the body. So for that reason, it is exponential continuous. And the last one of these is this linear, exponential, and is it discrete or continuous? This is linear discrete. It's a straight line, and there are dots, so it's discrete. All right, good work on those. Now we're going to move on to rules of exponents. So here's our summary page. In case you haven't gotten it down yet, this is a great one to take a picture of for your notes. These are all of our rules of exponents and radicals. You are allowed to use this on the test, so it's great to get a picture of it, get it in your notes. So what is 81 to the 1/2? We've got the applicable rule listed up there. Which one of these is the answer? 81 to the 1/2 is 9. And that is because we're using this rule up here, a to the m over n equals n root of a to the m. Well, here, m is going to be 1 and n is going to be 2. A is going to be 81. So if we reflect that over here, we'd have 2 root of 81 raised to the 1. Anything to the 1 powers itself, so this is just the square root of 81. Square root of 81 is 9. Now, it can be tricky to remember all these rules, make sure you're using the right one. Remember that this right here can just go in your calculator. You can just type that into your calculator and see what you get. If you get a repeating decimal, you might not know it looks like something like that. You might have to figure out something more. But because this is just a whole number, if you type that into your calculator, 81 to the 1/2, you'll get out 9. Always a good option to check these problems. How about this one? 4th root of 2 to the 5th. Which of these answers matches that radical? This one is C, 2 to the 5/4. So in here, 5, oh, we need to scroll up a little bit. 5 is the m and 4 is the n. So this is raised to the 5th, 4th root. So this is going to be same base to the 5/4. That's C. How about this one? 5 to the 3rd times 5 to the 4th. Which rule over here are we going to use? The answer here is 5 to the 7th. That's because we're going to add the exponents, 5 to the 3 plus 4, because we're multiplying. Next problem, 7 to the 4th over 7 to the 6th. Now we're using a different rule. How did we get 1/49 here? Well, we know that when we're dividing, we're going to subtract the exponents. So 7 to the 4 minus 6 is going to be 7 to the negative 2. And then we have to look at this additional rule, the negative exponent rule, that says a to the negative m is 1/a to the m. So this is 1/7 squared, 7 to the positive 2. And we know that 7 squared is 49, so this is going to be 1/49. This is our last exponent rule problem. It's kind of a complicated one. Take a second to look at it. What does this simplify to? All right, the correct answer is 9 to the 6th. How did we get that? Well, we know that when we're raising a power to a power, we're going to multiply. So that's going to be 2 times 4 up here. And then when we're multiplying exponentials, we add the exponents. So it'd be 5 plus 2 times 4. And then when we're dividing exponentials, we subtract the exponents. So we're going to subtract 7. So all together, this will be 9 raised to the 5 plus 2 times 4 minus 7. 2 times 4 is 8. So 5 plus 8 minus 7 is going to be 6. 13 minus 7, that's 6. So 9 to the 6th is our answer here. Excellent work. Okay, now we're going to be looking at earning interest. We talked about interest on bank accounts. So you currently have $300 in a bank account that pays you 3% interest every year. And there's the equation to describe this scenario. 300 is our beginning value. 1.03 is our common ratio because of that 3% interest. So how much money will you have in 8 years? How do you figure that out? Well, 8 means that that's the amount of time, so that's the number we're going to put in for t. P of 8 is 300 times 1.03 to the 8. If I put that in my calculator, 300 times 1.03 to the 8, I get 380.03 if I round. Now this is money, so we're going to round to the penny, round to 2 decimal places. So how much money did you have 5 years ago? How would we interpret that as time? What number would that be? 5 years ago. So this will be P of -5, but we do the same process. Now we just plug in -5 into the equation. 300 times 1.03 to the -5. And once again, I can just plug that into my calculator. 300 times 1.03 to the -5. I get 258.78. All right, so if we plugged in 8 here, and we plugged in -5 for 5 years ago, how much will you have in half of a year? What would we plug in then? This is going to be P of 1/2, and maybe we might write this as 0.5. 1/2 and 0.5 are the same thing. You can prove that to yourself by putting 1 divided by 2 in your calculator. And 0.5 is just a little bit easier to put into our calculator, so it might make sense to write it that way. So I'm going to say 300 times 1.03 to the 0.5. Put that in my calculator, and I get 304.47 if I round. So don't let these problems freak you out. They aren't overly hard, especially if they give us an equation. We did figure out how to derive an equation, right? We can tell this is exponential, we find the common ratio. But if they give you the equation, all you need to do is plug in that number. This is a substitution problem. So that wraps up our entire review for today. You're going to do great on the test tomorrow, and have an awesome day.